Hi, I'm Richard. I'm a speech and language therapist and a lecturer based in the UK. In today's video, I'm going to explain the speech and language therapy science behind a news story. In particular, how the brains of premature babies develop more if they listen to their mothers read Paddington Bear. The BBC published a news story about a research study which found that when premature babies heard their mothers read aloud stories of Paddington Bear, this helped their brains to mature and stimulated areas connected to language compared to other premature babies who didn't hear their mothers read aloud a story. The study the BBC wrote about was published by Catherine Travis and colleagues from Stanford University in the journal Frontiers in Human Neuroscience. Travis recruited 46 babies born prematurely who were still in a neonatal intensive care unit. The researchers recorded the voices of their mothers reading aloud the first chapter of Paddington Bear as if they were reading to their baby in person. Then they turned this into two separate 10-minute recordings. They randomly allocated the babies into two groups. One group would hear recordings of their mothers reading, whilst the other group would hear nothing. The researchers started the intervention when the babies were 32 weeks old to ensure that the part of the brain involved in speech perception was developed so the babies could actually hear the story. They set up iPods about 15 centimeters away from the babies' heads, then automatically played the two 10-minute recordings at pre-specified times each hour between 10 p.m. and 6 a.m. so the babies in the treatment group got an extra 160 minutes of maternal speech exposure per night, whilst obviously the other babies got nothing. To see whether there was any impact of the intervention, the researchers scanned all of the babies' brains using magnetic resonance imaging, MRI, before and after the intervention, then compared the scans of the two groups to see whether there were any differences. The researchers scanned parts of the brains called white matter tracts, which are bundles of nerve fibers that connect different regions of the brain and carry information between them like a road or highway. They looked at one of the white matter tracts which transmits information to areas thought to be involved in speech perception and production, known as the arcuate fasciculus. They also looked at other tracts known not to be involved, such as the corpus callosum, which allows the left and right hemispheres of the brain to communicate with one another. This was used as a control measure to check for any generalization of the intervention and overall brain growth over time. What they found when they compared the scans of the babies after the intervention was that those in the treatment group who had been exposed to the recordings of their mothers had denser and more mature white matter structure in their arcuate fasciculus in their left hemisphere, but not on their right side or in the corpus callosum. The left side of the brain is the one where language and speech processing is located for most people. Now, having denser and more well-organised white matter tracts is important because it allows the babies to transmit information between different brain regions more efficiently and reliably. Because all the babies were in the same intensive care unit, they were all being treated under the same conditions, as they excluded any babies that were too ill to take part, and they were randomly allocated to the treatment or control group. This allowed the researchers to suggest that the relationship between the speech recordings and change in brain structure was causal in nature. Nothing else could have explained the improvement. The researchers suggested that the additional speech provided by the recordings was comparable to the amount of speech that the babies might have heard or been exposed to in utero during the third trimester. The intervention closely approximated daily levels of speech exposure necessary for brain development. Now, research has shown for a while that babies in utero are sensitive to how words are spoken, what we call prosody, the rhythm, melody, pitch and intonation patterns of their mother's voice, which they begin to recognise from other speakers and prefer. They remember repeated sound patterns such as songs and familiar stories, and show preferences for these too after they're born, even when the sounds are no longer muffled by the mother's abdominal tissue, the uterine wall, and the amniotic fluid that surrounded them during pregnancy. This early language development, which occurs during the third trimester, is precisely what premature babies miss out on, and one of the reasons why they are at much higher risk of developing communication difficulties in the long term. This study demonstrates clearly that there is something that we can do about it. A final point: why Paddington Bear? The researchers selected Michael Bond's 1958 novel A Bear Called Paddington because it was a children's storybook available in multiple languages, which was important as the study took place in the USA, where there were lots of mothers who did not speak English as their first language, and because it would allow the researchers to capture a rich and continuous sample of maternal speech to play to the babies. So there you have it, the speech and language therapy science behind why Paddington Bear boosts preemie brains. If you found this video useful, give it a like and subscribe to receive notifications about similar videos in the future. If you've got any comments, questions, or have a request for other media stories to be covered in the future, then let me know in the comments below or get in touch with me on Blue Sky or Twitter. Otherwise, thanks for watching and take care.